Hello everyone. Today we discuss about molecular orbital energy diagrams. So they also belongs to molecular orbital theory. So already we discussed about what is importance of molecular orbital theory, and how it is better than valence bond theory, and what is the molecular orbital configuration, how to calculate the bond order, and how to know the magnetic character of that molecule with the help of a molecular orbital configuration. So the total characters are taken or we given in the form of a diagram that is called molecular orbital energy diagram. Okay, now we see molecular orbital energy diagram. Generally in shortcut it is known as MOED, molecular orbital energy diagrams. Now we see for different molecules. Okay, so first so just to a shortcut, a molecular orbital energy diagram. Okay, MOED of first write only H2. Okay, now we start with a simple molecule H2. We know that in H2 two hydrogens are there. Each hydrogen is having 1s1, 1s1. Means at first the mixing of 1s takes place. Already we know the mixing of 1s, the mixing of first hydrogen 1s and second hydrogen 1s. They combine together, they form a sigma star. Sigma star. So this is their average energy. One is formed lower than their average energy. The second one is formed higher than their average energy. Means the total energy will be equal. Okay, they must be in same size. Just try to give same size. Lower energy we know that sigma 1s. Higher energy we know that sigma star 1s. These are the new orbitals. Means same, but today we are giving a diagrammatic representation. Here how many electrons are present? 1s1, 1s1. Okay, 1 electrons are present. 1 1. The total becomes how many electrons? 2 electrons. According to Bohr principle, the first low energy will be filled. We know the configuration. With the help of configuration also we can know. There is no electron. Now already we know what is the configuration. The sigma 1s2, sigma star 1s0. So what is the MO configuration? MO configuration what? Sigma 1s, sigma star 1s. 2 here there is no electrons. Okay. So again we are trying to write bond order. So already we are perfect in the bond order. I think you are perfect in the bond order. So bonding electrons minus anti-bonding electron, that is equal to 1. So what is the magnetic character? So there is no unpaired electrons. It is a diamagnetic. Okay. So why it is diamagnetic? You have to write it. This is the MOED of molecular orbital energy diagram of H2, which is totally based on its configuration, molecular orbital configuration. See the next one. So molecular orbital energy diagram of N2. Okay, we know what is the nitrogen's configuration. 1s2, 2s2, 2px1, py1 pz1. Okay, what about second oxygen also having same 1s2 2s2 px1 py1 pz1. Okay, okay, write it neatly. Okay, so for second hydrogen also the nitrogen is 1s2. So the intermixing of 1s 1s. Okay, first mix the 1s 1s. So we need to draw the diagram from bottom, because at first we are giving importance for lower energy. At first lower energy field, then higher energy field. So take 1s here, 1s are combined together. And what are the formation? Sigma 1s, sigma star 1s. Okay, here sigma 1s, here the formation of sigma star 1s. Okay, try to give same size. Okay, try. Next, here 2s combined with this 2s. And what are the giving? So they must be in one line. Okay, so it also forms two new molecular orbitals. So what are their names? Sigma star 2s, sorry, sigma 2s, sigma star 2s. Then what about the 2px, 2px, 2py, 2py, 2pz, 2pz? So on this mixing we will get a different one. So I am writing 2px, 2py, 2pz. 2px, 2py, 2pz. So I am giving the circle shape. In some books it may be given the square shape. So it is just our choice. Here totals, they must be in one line. Try to give one line. So it's a px, py, pz. Next, here also again there is a 2px, 2py, 2pz of second nitrogen. So they combined together. Total how many participated? 3. Total 6 are participated. The 6 will be formed. Or 6 will form with half a low energy, half a more higher energy. Okay. So 3, for example, 2 formed. One is low, one is higher. Here also 2 formed. One is low, one is higher. Okay. Here total 6 formed. 3 are in lower level, 3 are in higher level. Take an important one. The lower level also, the first connection is having sigma. Okay, next 2 connections are having pi bonds. So that's why mali bottom low, so down low form 3 lo kuda 2 pi's are having same energy, 1 sigma is having different energy. So already we know the configuration. So here total how many electrons? 7 plus 7, 14 electrons. So we need to take the 14 electrons configuration. That is so ఇలా 3 ఫామ్ అవుతాయి. సో ఆ 3లో మనకి these are pi 2py, pi 2pz. So it is sigma 2px. Okay, next. So this is pi star 2py, pi star 2pz. I am removing this. So at last we know that sigma star 2px. So these are the 6 molecular orbitals. In these 6 molecular orbitals, the filling of electrons, first we give the names. So what is the name of this? Okay, this name is sigma 2px, its name. Okay, what is its name? Sigma star. So it's not 2px, it's 2s, 1s, brother. 1s to combine is sigma 1s. What is this? Sigma star 1s. What is this? Sigma 2s. What is this? Sigma star 2s. So what are these two? We know the configuration. Pi 2py. This is pi 2pz. What about this? This is sigma 2px. So what about this? It is pi star 2py. So it is pi star 2pz. Okay. So this is at last sigma star 2px. Okay. So we have very small size. So you need to draw perfectly with a bigger length. Okay. Now fill that electrons. So these are the order. It is exactly equal to its configuration. See, for sigma 1s, from top to bottom energy increases. You need to remember, from top to bottom energy increases. Energy increases. Okay. Now what are the configuration? There is a 1s2, 1s2, 2s2, 2s2, 2px1, y1, z1, 2px1, y1, z1. This is for nitrogen, we know that. Now fill that here total 2 plus 2 electrons. 2 plus 2, 4 electrons. First lower level complete double 2. Next 3, 4. Then I will make it a 2 plus 2, 4. 1, 2, 3, 4. Next total 3 plus 3, 6. So 6 electron fill pi 2py is equal to pi 2pz. So come first into 1 1 fill up. So it's completed 6, 1, 2. Next third one, fourth one, fifth one, sixth one. So here there is no electrons are present. Now you need to write the configuration. So just simply see, normal already we know about the configuration. So you have to write the configuration, bond order. So it is totally your work, that writing the configuration. So just below this diagram you have to write molecular orbital configuration. Next you have to write bond order, and you have to write magnetic character. Okay, so already we done many times in the board. You have to write in your own terms, in your own words. Okay, without seeing the notes, you have to write this configuration. Already it is present here, you have to complete it. Okay, complete the 3 points below the diagram. Okay, let's complete it. So diagram must be very neat. Next, we see the molecular orbital energy diagram of. So this is below 14 electrons, and nothing but 14 electrons, below 14 electrons, same. Now we see one diagram for above 14 electrons. Now you see molecular orbital energy diagram of oxygen. So oxygen means what is the each oxygen configuration? 1s2, 2s2, same 2px1, y1, z1, is it correct? So total మనకి 8 electrons రావాలి కదా, 2px2, y1, z1. Second oxygen also having same 1s2, 2s2, 2px2, py1, pz1. So again it is looking same combinations. It is looking same combination, that is like N2. So N2 low 1s combined. So I am not giving the diagram again. You have to draw separately. Okay. So here 1s2 of these two combined, forming sigma 1s, sigma star 1s. And the 2 plus 2, 4 electrons are filled. Here 1, 2, then 3, 4. Then 2s2, these two are combined. These two are combined and forming molecular orbital sigma 2s, sigma star 2s. Both are having 2 electrons, total 4 electrons. 1, 2, 3, 4. Next, here also px, py, pz combination. Also here the arrangement is different. Okay, that's why we removed this diagram. We need to draw the diagram separately because it is differ. So we can have 1s combination, 2s combination is same in all that molecules which are having 14 electrons and above 14 electrons. So ekkada configuration difference vaste manaki. So after 2s tarvata 2px, 2py, 2pz energy order is only difference. When you compare the energy levels of molecular orbitals below 14 and above 14 electrons. Okay. So here the combination of 2px, py, pz. So the place is not sufficient. So again 2px, 2py, 2pz. Here also same 2px, 2py, 2pz, 2 for all. Now there is also 6 are formed. In that 6, 3 are having low energy, 3 are in higher energy. Again that low energy low, 1 is sigma, remaining are pi. So that energy difference above 14 electrons. So according to MOT theory, it's a molecular orbital theory. So they are like this. So at one position there is a difference because already we know the configuration. So here only difference, remaining total is exactly equal. Okay, so what is the number of electron? I think number of electrons are different. Here 2px2, y1, z1, x2, y1, z1. Also in nitrogen there is only total 6 electrons are there. Here there is 8 electrons are there. 4 plus 4 electrons. Okay, 4 plus 4 electrons in the first field. So what is the names of this? The sigma 2px. It is pi 2py, pi 2pz. They are having same energy. That's why in the configuration we used you maintain the is equal symbol. So what about this? So this is called pi star 2py. This is pi star 2pz. This is sigma star 2px. Now feel that 4 plus 4, 8 electrons. 1, 2. Next 3. So 4. So 5, 6, 7, 8. Okay, same energy government on 1 fill up chair. According to Hunt's rule. So according to Hunt's rule, the 2 are same level. Same level we need to fill that orbitals with 1 electron. So 1 electron complete into the next electron need to add shell. Okay, so that is called Hunt's rule. First low energy fill up station, then you go to the higher levels. That is half-bow principle. If the same energy orbitals are called degenerate orbitals. In degenerate orbital, filling of electron takes place according to Hund's rule. So what is Hund's rule means? The electrons filled in the degenerate orbitals with the 1 electrons. Then only pairing takes place. Okay. So again you have to write the configuration. This is vacant. So two unpaired electrons are present. So it is a paramagnetic. What is the bond order? Bonding electrons 2, 4, 5, 6, 7, 8, 9, 10. 10 minus 4, 5, 6. 10 minus 6 by 2. We get the bond order 2. So configuration means simple. Sigma 1 is 2, sigma star 1 is 2, sigma 2 is 2, sigma star 2 is 2, sigma 2px2, pi 2py2 is equal to pi 2pz2. Next pi star 2py1, next pi star 2pz1. Okay, so you have to write the points below the diagram. So both N2 diagram must be separate in one page. This O2 diagram separately in one page. Okay, you have to write these details. And the energy line is so from top to bottom energy increases. We know that. Okay, just means so you see this is the average energy. So sigmas are having lower energy than normal atomic orbitals. Sigmas are having means all stars. So stars having high energy compared to the atomic orbitals. Okay. So మన ఫస్ట్ దానికి ఈ లైన్ మీరు రాయాల్సిన అవసరం ఇట్స్ నాట్ నెసెసరీ. ఇఫ్ ఒక లైన్ డ్రా చేస్తే వెరీ థిన్ లైన్ డ్రా చేయండి. ఓకే, నాట్ ఎ థిక్ లైన్. ఓకే, సో ఇక్కడ దిస్ ఈజ్ మెయింటైన్స్ యావరేజ్ ఎనర్జీ. సో molecular orbitals are lower than atomic orbitals in energy terms. That's why they are more stable. These are with high energy with less stability. Here also, and here also in the formation in the former 6 3 are in lower level, 3 are in higher level. So mali 3 lo kuda all are not having same energy because 1 is sigma, remaining are 2. It is observed that difference is present below 14 electrons and above 14 electrons. Okay, this is the, and you need to write these points. Complete the points at the below of the diagram. Okay, next we see one more molecule. Next molecular orbital energy diagram of H2 plus. So you know the height H2 plus means total how many electrons? There is only one electron. Okay, H2 plus. The total number of electrons is 1 plus H plus. H2 plus means 2 hydrogens, 1 plus 1. So it's minus 1. There is only one electron. Okay, then what will be the configuration? What is the molecular orbital configuration? So sigma 1 is, sigma star 1 is only one electron. It's 1, it is 0. Simple. So it's magnetic character. What is dia or para? So one electron is there. So it is paramagnetic. So paramagnetic. Because you know that it has one unpaired electron in 1s. Okay. You see the diagram. The 1s of one hydrogen, 1s of other hydrogen. They combine together, forming two orbitals, molecular orbitals. Here total there is only 2 electrons are present. Okay, combinedly they lose a, mean there is only 1 electron is present. Sigma minus sigma star minus. So what is the bond order? So bond order is bonding electrons 1 minus 0 by 1, that is equal to this point. 1 by 2 is the bond order. Okay, so now I give some questions. Some questions based on molecular orbital theory, not exactly in the diagrams. So try to solve these questions. Okay, they are not multiple choice questions. So the question is when nitrogen changed to nothing but when nitrogen goes to N2 plus, the N bond and distance increases or decreases. You have to fill that. Okay. Next, when O2 is changed to, when O2 is goes to O2 plus, the oxygen bond distance increases or decreases. You have to write. Next, so arrange O2 minus and O2 plus in the increasing order of their bond length. Okay. Next, one more question is there. Write the molecular orbital configuration of B2 and F2 molecules. So to make the perfect about the configurations and characters, you have to practice this. Okay.